Indiana University East, Department of Science, naming aldehydes and ketones. So we're going to focus on functional groups that contain the carbonyl group, and we're going to start with those that don't have anything other than hydrogen or a carbon chain here. If it's just as a hydrogen here, then we have an aldehyde, and whereas if we have another carbon chain here, then we've got ketone. Note that pure aldehydes and ketones cannot have hydrogen bonds because there is no NH, OH, or FH bonds present. So let's look at how we name aldehydes. So here, again, we look at the chain containing the aldehyde group. This is my aldehyde group. And 1, 2, 3, 4. So that's but. And there's nothing else there other than the aldehyde. So this is butanal. Because the aldehyde is obviously in the first position, we do not need to label it. Let's look at this one now. The longest chain here would be this one. This is the longest carbon chain. And now, so if I label the numbers 1, 2, 3, 4, 5. This is a pentan chain. And then so this is pentanal. Okay, and we look at the substituents. We have an ethyl group at the 2 position and a methyl group at the 3 position. So it's 2 ethyl, 3 methyl, pentanal. So let's draw some. Here we've got 2 methyl butanal. So let's draw the but. So we have 4, 1, 2, 3, 4. And at the 1 position we have the aldehyde group here. And so this is my 1 position, this is my 2 position, and I have a methyl group here. Now with octanol, 3,4-dimethyl octanol, 1, 2, 3, 4, 5, 6, 7, 8. Okay, the first position I'll put an aldehyde group here because of the al, and I have methyl groups at the 3 and 4 positions. So 1, 2, 3, 4. So that would be the structure of 3,4-dimethyl octanol. Now ketones, let's see how we can draw these. Let's start with this one. The main carbon chain has 5 members. So pentan, and then the functional group is in the 3 position. Let's see, 1, 2, 3, 4, 5. It doesn't matter how you count it. So pentan 3-one. So in this case, because it's in the middle, it doesn't matter which way I count. Okay. Now, as usual, we will try and minimize the number for the carbonyl group. So 1, 2, 3, 4 here in this case. So I have butan 2-one, and I've got substituents in the 3 position, 2 methyl groups. So it's 3, 3 dimethyl. Okay, so it's more like I've put an extra hyphen there. 3, 3 dimethyl butan 2-one. Let's look at some more complicated examples now. Here, let's look at what our main chain would be, and we'll go for the longest one. So I'm going through, highlighting. I need to go down here, and now I'm going to start numbering from here because it's closer to the ketone. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's non-N, and then 2-one. And let's look at everything else. Here I have a methyl group at the 3 position, and I've got an ethyl group at the 6 position. So 6 ethyl, 3 methyl, non-N 2-one. Lastly here we have a cyclohexane ring being the main group, and we take the ketone group to be number 1. And this is understood. This is my second position. So this one, I have 2 ethyl, because that's my substituent here, cyclohexanone. And because the numbering position is clear, I don't need to put it down there. Okay, so let's take a look at this. Here I have a pent chain, 1, 2, 3, 4, 5. Let's number these. 1, 2, 3, 4, 5. What have we got here? We have the free position having a double bond. Now this seems a little odd here, but it will make sense in a bit because we're going to give the ketone priority. So here, the C double bond O shows up in the 2 position, so that forces this into a free position. Now, in the 4 position, we have a methyl group here. So this is a methyl group. Now let's look at this last one. I have a bute, so 4. 1, 2, 3, 4. Now then this is an odd one. So I have a double bond at the 2 position, and then I have an one here. And then I have a phenyl group, so an aromatic ring in the 1 and 3 positions. And that is the structure of 1,3-diphenyl butene 1-one. Lastly, let's look at this. So I've got cyclopentanone. So I'm going to start with a cyclo for 5 positions, with a carbonyl group here. And then I'm going to start with 1, 2. So I have 2. So this is my 1 position. So there's 2, 3, 4. I have 2 methyl groups at my 2 position, and 2 methyl groups at my 4 position. And so this is 2, 2, 4, 4 tetramethyl cyclopentanone. Again, because my ketone group defines my number 1 position, that is how it's going to be. And we don't need to put down 1 here.